Standard 7th, Subject Geography. Chapter 8, How Seasons Occur, Part 2. In this chapter, let us learn about apparent movement of the sun. You must have realized through your observations that the position of the sun at sunrise appears to change on the horizon every day. Its position appears to move towards the north or the south in the course of a year. So you either see the sun moving towards the north or towards the south in the course of a year. But however, in reality, the sun does not move anywhere. That is why this movement of the sun towards the north or the south in a year is called the apparent movement of the sun. The position of the rising sun keeps on moving towards the south in the period from 21st June to 22nd December, right up to here. So, this period is called Dakshinayan from 21st June year to 22nd December. We call this period as Dakshinayan as the position of the rising sun keeps on moving towards the south. Okay. Next, from 22nd December, from here, right now what we have 22nd December to, suppose say 22nd December is here. From 22nd December to 21st of June, the sun keeps on moving towards the north. Is the sun actually moving? No, the earth is moving, but we see from the surface of the earth as if the sun is moving. From 22nd December to 21st June, the sun keeps on moving towards the north. You can see the north side is now tilted towards the sun. So this period is called Uttarayan. So this entire period from 22nd December to 21st June is called Uttarayan, and from 21st June right up to 22nd December is the period of Dakshinayan. The revolution of the earth around the sun and the tilted axis of the earth are the two factors responsible for the apparent movement of the sun. Seasons occur only with reference to the northern and southern hemispheres. Now let us learn about perihelion and aphelion positions of the earth. The path of the revolution of the earth around the sun is elliptical. We all know about this already. We have studied that the path of the revolution of the earth when revolves around the sun, this path which you see the dotted line is elliptical. Okay, that is oval in shape. The sun is at one of the two centers of the ellipse. This is one, the other one is the center. Okay, the sun does not change its position as the earth moves in an ellipse. Its distance from the sun does not remain the same. Here you can see when the earth will reach here, the distance is so less. Here it's far, here it's comparatively closer than this. So the distance matters as the earth moves around the sun in elliptical orbit. This distance, you can see this oval shape, the distance differs. So it is at its minimum distance in the first week of January. So here you see in the first week of January, the earth, you can see it is at its minimum distance. Okay. Now, this is the actual figure of the Earth's elliptical orbit which we are going to study. So here it's shown 147 million kilometer. Okay. On the other side here it is shown 152 million kilometers. This is when the Earth is closest to the sun, minimum distance. So this is called the perihelion position. Perihelion. So perihelion position of the earth is when the earth is closest to the sun compared to the other distances. And next, before that, in this position, the perihelion position, the southern end of the axis is towards the sun. You can see the southern end of the earth's axis is towards the sun. Okay, as against this, means as opposite of this, if you come this side, in the first week of July, somewhere around in July, the earth is at the farthest point from the sun. So, maximum far. This is called the aphelion position. In this position, the northern end of the axis is towards the sun. So, with the help of figure 8.1, which shows the position of the earth in relation to the sun, you can guess which season prevails in which hemisphere. Seasons occur due to the revolution of the earth as well as due to the tilt of its axis of rotation. As the earth revolves around the sun, the equator receives perpendicular rays on 2 days in a year. So you can see the equator receiving perpendicular rays of sun. This happens only during 2 days in a year. This condition occurs on 21st March and 23rd September. On these days, both the poles are at the same distance from the sun. This is called equinox, when the day and night are of equal duration. When does it happen? 21st March and 23rd September. The illuminated and dark portions of all the parallels, including the equator, are shown in figure 8.3. This is the illuminated part, the blue color which you see, illuminated part facing the sun, and this other part, that is the one which is showing lines. Okay, dark portion. This dark portion, it is away from the sun. So, in the figure, the circle of illumination divides all parallels from the North Pole to the South Pole equally. Okay. Everywhere on earth, nighttime and daytime are of equal duration. This condition is called equinox. So, what is equinox? When the day and night are of equal duration everywhere on the earth. On equinox, the sun rays are perpendicular on the equator. So you can see here the equator is directly facing the sun. In this condition, the circle of illumination coincides with the great circle defined by two opposite meridians. So in the northern hemisphere, spring prevails. From when? From 21st March. Okay, from here 21st March to 21st June year. From 21st March to 21st June, we see spring. And from 23rd September, that is year, 23rd September, which is another equinox, we call it autumnal equinox. From 23rd September to 22nd December, there is autumn. The southern hemisphere has the opposite seasons during this period. This is about the northern hemisphere. So, in the northern hemisphere, 21st March is called spring or vernal equinox, whereas 23rd September is called autumnal equinox. The equinox or solstice dates can vary by a day or so. When any of the poles inclines the most towards the sun, that is 23 degree 30 minutes parallel of that hemisphere receives perpendicular sun rays. So in this figure A, you can see that the North Pole has inclined maximum towards the sun, and here due to this maximum inclination you can see Tropic of Cancer, which is 23 degree 30 minutes parallel directly perpendicular to sun rays. Okay, the sun rays are perpendicular at the equator on 22nd March and 23rd of September. So on equator you will see on those equinox days, which are the days of equinox, 22nd March, or rather you say, and 23rd September. After these days, that is after 22nd March, other parallels between the equator and the Tropic of Cancer in the northern hemisphere start receiving perpendicular rays sequentially. So from 21st March onwards, other parallels will start receiving perpendicular rays. On 21st March, we have the equator directly facing the sun perpendicular. From 21st March, from equator till Tropic of Cancer, you will see that they start getting maximum sunlight. So Tropic of Cancer in the northern hemisphere starts receiving perpendicular rays sequentially. Only on 21st June and 22nd December, the sun rays become perpendicular on the Tropic of Cancer here and this side in the southern hemisphere Tropic of Capricorn respectively. So these 2 days are called the solstice days. Okay, 21st June and 22nd December are the solstice days. When on 21st June the sun rays are perpendicular, you can see here in this figure on Tropic of Cancer. And on 22nd December the sun rays are perpendicular on Tropic of Capricorn. So these are our solstice days when sun rays are perpendicular at 23 degree 30 minutes parallel in the northern hemisphere on 21st June and in the southern hemisphere on 22nd December respectively. So these are our solstice days. So right now you have studied about the equinox days. Okay, and now you have learnt about the solstice days. So 21st March and 23rd September are the equinox days, which are called as spring and autumnal equinox, and 21st June and 22nd December are the solstice days. 21st June and 22nd December. Now, sun rays are never perpendicular on any of the parallels between Tropic of Cancer and the North Pole or between Tropic of Capricorn and the South Pole. Means as you move from the Tropic of Cancer towards the poles here, the sun rays will never be perpendicular. Also similarly, from Tropic of Capricorn to South Pole, the sun rays will never be perpendicular. So, 21st June is the longest day and it marks the shortest night in the northern hemisphere. Similarly, 22nd December marks the longest day and the shortest night in the southern hemisphere. 22nd December is the shortest day. Here you can see in the northern hemisphere. Okay. In the northern hemisphere, we can see 22nd December as the shortest day because here you see in the north, it is away from sunlight. So, whichever part of the earth is facing, whichever pole you can say is towards the sun, that part is facing summer, and which is away from the sun is facing winter. Long days and here longer nights. Shorter days, shorter nights and here long nights. So it depends all upon the revolution of the earth, the cycle of seasons. So you have learnt about equinox days and you have learnt about the summer solstice which happens on 21st June and the winter solstice, which happens on 22nd December. Okay, you have to remember these dates. This is the cycle of seasons, as well as the diagram shows you summer solstice, winter solstice, spring equinox, and autumnal equinox. Now, in the region from the Arctic Circle, where is Arctic Circle? Here in the north. From Arctic Circle to the North Pole, the sun remains visible for 24 hours or longer, because you can see hardly the sun rays fall here. The sun rays fall perpendicular, sometimes on equator, sometimes on Tropic of Cancer, Tropic of Capricorn, but never beyond this. Beyond Tropic of Cancer, sun rays are never perpendicular, they come slant. Okay, so it happens that sun remains visible for 24 hours or longer, sometimes in the Arctic Circle. At the North Pole, the sun is visible in the sky from 22nd March. Okay, here you have 21st March. So from this period to 23rd September till here, for 6 months, the sun remains visible at the North Pole. For how many months? For total 6 months. Similar situation prevails in the region between Antarctic Circle and the South Pole. In the period from 23rd September now, okay, to 21st March. Same situation happens in the South Pole. You will see the South Pole will remain in sunlight for 6 months here. So North Pole remains, the sun remains visible for 24 hours from 21st March to 23rd September, and from 23rd September to 21st March, the South Pole, in the South Pole, the sun remains visible for 24 hours. Note that on equator, the duration of day and night is same throughout the year, that is 12 hours each. Now, the seasons have been decided on the basis of the duration of sunlight, equinoxes, and solstices. The equatorial region does not experience any change of season. Hence, the climate in that region does not change at all in the year. In places beyond here we have the equatorial region. Now, in the places beyond the equatorial region, what happens there? In either hemisphere, summers or winters are experienced one after the other within a year. The occurrence of seasons one after the other in a year leads to the cycle of seasons. Generally, there are two seasons. Summer, here you have summer, and winter. Summers or winters are experienced one after the other. So we have generally summer or winter, these two seasons on the earth. However, in some places, seasons are taken to be 4 in all. The changes in the atmosphere, vapor, which is in the air, the wind, and the precipitation also influence the seasons. So seasons not only depend upon the revolution of the earth but also on these 4 factors. Continuous occurrence of rain is in a specific period gives rise to an additional season besides summer and winter. Due to the local conditions, seasons other than summer and winter are seen to occur in different parts. For example, rains occur in India in a specific period. Therefore, we consider 4 seasons such as summer, the rainy season, the period of retreating monsoon, and winter. There are 4 seasons in Europe and North America too. They are summer, autumn, winter, and spring. Now let us learn more about the cycle of season and the living world. If the Earth's axis were not tilted, the same climatic conditions would have prevailed throughout the year. The season would have not occurred. One and the same type of climatic conditions would have prevailed on each of the different parallels. It is the tilt of the axis that leads to the occurrence of seasons, change, and diversity on the earth. The living world on the earth is affected by the cycle of seasons. For example, in the region between 66 degree 30 minutes here, from where we start the Arctic Circle, and 90 degree, this region, this entire region on top, that is the North Pole. Okay, in both the hemispheres, that is in the North and the South Pole, towards what happens, even the mild sunlight available for a part of the year give rise to certain flora and fauna. Mild sunlight is observed there as the sun rays are slanting towards the North Pole and towards the South Pole. So, in the Antarctic region at the southernmost part of the earth, birds like penguins, fish like seals, and animals like walruses are found. In the polar region of the northern hemispheres, animals like reindeer, polar bears, Arctic foxes, etc. are found. People living in this region too have adapted to the natural conditions prevailing in that region. Our adaptation to climatic conditions is possible only up to certain limit. That is why organisms prefer a certain habitat. During extreme cold climatic conditions, when the food supply becomes scarce means less, a number of birds and animals migrate temporarily. What is migration? Moving from one place to other. Okay, moving from your a place where you live, and migrating means going to some other place. So trees bear fruits in a particular season. Therefore, agricultural seasons also depend on the local climatic conditions. So this is all about the cycle of seasons and how it's affecting the living world. Do you know Arctic tern? You can see it in the picture. Once the winter at the North Pole becomes severe, this bird travels southwards. When it is summer in the northern hemisphere, it flies back towards the North Pole. So it migrates. In other words, this bird migrates for a certain period of time. It has to travel in search of food. In the course of 1 year, it travels 70,000 kilometers. It might be the only species in the world that experiences summer twice in a year because of its migration. Next, we have a Siberian crane. Due to severe winter and lack of food, cranes from the cold northern regions visit India traveling around 8 to 10,000 kilometers. Once summer starts in India, they migrate back to the north. So this way we see animals get adapt themselves to the situation, and sometimes they even have to migrate. So migration is seen in not only in human beings, not only human beings migrate, but animals and birds also migrate. So hope you have understood this chapter. Do read your textbook for a better understanding. Stay safe, keep learning, and thank you.